Okay, I got a PM and somebody was suggesting to me, geriatric guru to be specific, that I might, just in the title of the PM, that I might do a video on the subject, and he's right, it's interesting, so I will and I am. He sends me the text of an article. New theory nixes dark energy, says time is disappearing from the universe. Interesting idea, you know. Okay, so this is similar to the idea that it's not really dark matter, or dark energy, but the laws of physics are wrong. There's a thing called modified Newtonian dynamics, for example. Okay. Anyway, remember a little thing called the space-time continuum? Well, what if the time part of the equation was literally running out? New evidence is suggesting that time is slowly disappearing from our universe and will one day vanish completely. This radical new theory may explain a cosmological mystery that has baffled scientists for years. Scientists previously have measured the light from distant exploding stars to show that the universe is expanding and accelerating at an accelerating rate. Specifically, the further away things are, the faster they are going away from us. They assume that these supernovae are spreading apart faster as the universe ages. Physicists also assumed that a kind of anti-gravitational force must be driving the galaxies apart, and started to call this unidentified force dark energy. However, to this day, no one actually knows what the dark energy is or where it comes from. Professor Jose Sinu Villa and his colleagues at the University of the Basque Country in Bilbao, Spain, have proposed a mind-bending alternative. They propose that there is no such thing as dark energy at all, and we're looking at things backwards. Serenovia proposes that we have been fooled into thinking the expansion of the universe is accelerating, when in reality time itself is slowing down. At an everyday level, the change would not be perceivable. However, it would be obvious from cosmic scale measurements tracking the course of the universe over billions of years. The change would be infinitesimally slow from human perspective, but in terms of the vast perspective of cosmology, the study of ancient light from suns that shone billions of years ago, it could easily be measured. The team's proposal, which will be published in the Journal of Physical Review, dismisses dark energy as fiction. Instead, Professor Senovia says the appearance of acceleration is caused by time itself gradually slowing down, like a clock with a run-down battery. We do not say that the expansion of the universe itself is an illusion, he explains. What we say it may be an illusion is the acceleration of this expansion, that is, the possibility that expansion is and has been increasing its rate. If time gradually slows, but we naively kept using our equation to derive the changes of the expansion with respect to a standard flow of time, then the simple models that we have constructed in our paper show that an effective accelerated rate of the expansion takes place. Currently, astronomers are able to discern the expansion speed of the universe using the so-called redshift technique. This technique relies on the understanding that stars moving away appear redder in color than ones moving toward us. Scientists look for supernovae of certain types that provide a sort of benchmark. The theory bases its idea on one particular variant of superstring theory, in which our universe is confined to the surface of a membrane or brane floating in a high-dimensional space known as the bulk. In billions of years' time would cease to be time altogether. These ideas are not without support. Gary Gibbons, a cosmologist at Cambridge University, says that the concept has merit. We believe that time emerged during the Big Bang, and if it can emerge, it can also disappear. That's just the reverse effect. So that's interesting. And I guess it's New Scientist, which always has interesting stuff. Now, it's not a new idea that the dark energy and dark matter might just be evidence of error in physical laws. In other words, our understandings of how gravity works, or maybe the gravitational constant changes. There's also this thing that Pioneer, or whatever it is moving away at the wrong speed. Even taking relativity into account, it's moving away at the wrong speed. So, there's some evidence that well, there always is, that we should consider changing the laws, the fundamental laws, the rules, okay, the principles. Now, the search for a substance, we used to assume there's a substance everywhere. In a way, there is. They're still looking for substance of vacuum in these Higgs bosons, that there's particles, that things always have substance. And of course, I believe that things always have to have substance. However, time having substance is such a weird abstraction that, for all intents and purposes, we're talking about time being one of the fundamental rules, of the universe. And the idea of thinking of the universe without time running is kind of hard. I mean, we pretty much think of the universe as a thing where time takes place. Something like this is possible, like they said at the end of the video. Now, they're talking about dark energy, and as far as I know, that there's no proof whatsoever, actually I'm sure there isn't, of dark energy having a material form. But there is for dark matter. And so with the same thing happens with dark matter. Now, how they found out that, that there was all this unseen matter was they looked at galaxies rotating. Now, you can do this because of that redshift and blueshift effect. One side of the galaxy seems red and one seems blue because it's spinning. And so you can tell how fast it's spinning even though you don't have time to see it spin. So they found out that these galaxies are spinning much too fast for how much matter we can see in there. So the first thing they did is they looked for baryonic matter, ordinary matter. Like maybe it's just dark gases and things, and they're thick clouds of gas that we don't know about. The thing is, you can see that kind of stuff. Why? Because there's stars inside it and on the other side of it, and the light comes through it, and you can see the light that gets masked out through spectroscopy. You can see what kind of chemicals are in between you and your light source. So they really, and in a galaxy, there's a lot of stars, so they should be able to see, a lot of this matter at least, and there's huge amounts of it that are missing. Okay, so what do you do? What do you do? Well, they think maybe there's this kind of weird matter that, is invisible to us, but has gravitational interaction, like boulders, but they just fly right through our boulders and through each other. So now that's the thing. In 2006, there was a very careful study done that's very, very strongly in favor and arguing towards the fact that dark matter, at least, is a material substance. And what they did is they took two galaxies that are colliding. Now, because of all the mass there's an effect called gravitational lensing, and that's where when you have a gravitational force, light bends, right? Einstein figured that out. Light bends around the sun, it bends around. Well, that means that it has a lensing effect, okay? So you can see things behind a big object. And now all the time there are these the lensing effects that you can see very directly, that there'll be like one star and a little smear, and that smear has exactly the same color. And it's because in between us and it is some other massive object, and the light can actually be bent around galaxies and whatnot, and lens. Well, what they did is look at something called microlensing, because that's a very obvious case. But the fact is, this distortion is happening all the time. So they took a bunch of background objects behind these galaxies colliding, and they looked for microlensing events, and they got a gravitational field. In other words, looking at the starlight we got and the way it was smeared and blurred out, they deduced what mass had to be in there to do the bending by mass. Now, they got this map, and there's two galaxies colliding, and what they found is that all the baryonic matter that we can see, the glowing stars and stuff, they have the shape that we expect, that we can see, of course. But where we can't see, there's a bunch of mass that is the dark matter evidently, where it also collided, but since it doesn't bump into itself or us, it just went through. So while two galaxies collided, like two things colliding, the dark matter just flows right through. Okay, all the regular mass is slowed down by gases and all kinds of contact in this kind of collision, where stuff is all stirred up, and the dark matter just sloshed right through and is just sloshing back and forth. So dark matter at least looks like real stuff. So I have to say, I don't really get dark energy. I don't even think a lot of physicists do, but I certainly even less so. And why there would be this light, this pressure, energy pressure expanding the universe. And I'm open to the idea that it could be something more like, time slowing down, making it look like that. That there's another perspective that'll make it look like the expansion. On the other hand, I'm also okay with universe with no actual center, or you could say every point in it is its geometric center, that's expanding in all directions, where everybody is equally distant from it, and that it just expands until the energy dissipates. I mean, I'm actually, I'm fine with whatever it is. I'm just very curious as to which one it'll turn out to be.